Hello and welcome to Hyperledger Fabric architecture. We all know IBM has gone public with its work and by providing a leading role in the Hyperledger project. And we also discussed in our previous sessions about the Hyperledger Fabric and offerings provided by IBM. Let's now look into the Hyperledger Fabric architecture and its components and how they can be used. Here is an overview of the Hyperledger Fabric project reference architecture. The reference architecture is aligned in three categories: membership, blockchain, and chain code services. These categories are logical structures and not a physical depiction of partitioning of components into separate processes, address spaces, or virtual machines. First, let's look at the first category, membership services. What does membership services provide? Membership services provide services for managing identity, privacy, confidentiality, and auditability on the network. A permission blockchain participation requires authentication and authorization for all nodes to submit transactions and accept them into acceptable blocks. The second category, blockchain services. What do these blockchain services do? These blockchain services manage the distributed ledger through a peer-to-peer protocol built on HTTP, HTTP2. Finally, the third category, which is very critical, chain code services. Chain code services provide a secured and lightweight way to sandbox the chain code execution on the validating nodes. All the components in these categories emit events on the blockchain network that may listen for and to take action. Event Hub captures all those events. Hyperledger Fabric also has different types of interfaces to interact with these type of categories. These interfaces include APIs, CLIs, and SDKs. Next, we will be talking about each of these interfaces. As we saw, Hyperledger Fabric offers you with three interfaces to interact with membership, blockchain, and chain code services. Now let's take a deeper look into each of the interfaces. First, let's start with Application Programming Interface, or API. The primary interface to the Fabric is the REST API. The REST API allows applications to register users, query the blockchain, and to issue transactions. All of our API calls have standard HTTP endpoints and they use JSON formatted responses. So any language will work just fine. Next interface is CLI. The CLI is also provided to cover a subset of available APIs for development purposes. This enables developers to quickly test chain codes or query the status of transactions. Final interface is SDK. Hyperledger includes SDK for applications to communicate with the network. Typically, applications interact with a peer node, which requires some form of authentication to ensure that the entity has proper privilege. Also, some messages from a client need to be signed to verify the client identity and are also verified by the peer node. The Hyperledger Fabric API covers categories or provides API for categories like identity, address, transaction, chain code, blockchain, network, storage, and event stream. You can work with the REST APIs through any tool of your choice. For example, the curl command line utility or a browser-based client such as Firefox REST client or Chrome Postman. You can likewise trigger REST requests through Swagger. Now let's see what Hyperledger Fabric membership services provide. Membership services provide capabilities for managing identity, privacy, confidentiality, and auditability on the network. To guarantee that transactions are secure, private, and confidential, each participant must register with the proof of identity to obtain network membership and also to gain access to the system. Membership services combine elements of public key infrastructure and consensus to transform non-permissioned blockchain into a permissioned blockchain. There are different levels of permissions available on the network that range from liberal to restrictive. Moving on to the key functions provided by membership services, let's talk about first key function, registration. The approach taken to reconcile identity management with user privacy and enabling competitive institutions to transact effectively on a common blockchain is done through registration process, that is, issuing a certificate identifying a member. There are two types of certificates through which authentication can happen. The first one, e-certs, which are also called static enrollment certificates. These are acquired via registration with an enrollment certification authority. These are long-lived certificates and are issued for all roles, including those of users and also peers in the network. The second one is T-certs, which are also called transaction certificates. These faithfully represent enrolled users acquired via transactional certification authority. These are short-lived certificates that are issued for a transaction and can be configured to not carry any user identity information. Now let's see another key functionality provided by the membership services, attributes. What do these attributes do? Attributes issue keys for members to transact, ensuring privacy. They provide a PKI or public key infrastructure framework based on public key cryptography that ensures not only the secure exchange of data over public network but also affirms the identity of the other party. A public key infrastructure or PKI manages the generation, distribution, and revocation of keys and digital certificates. These services validate users' identity, register the user in the system, and also provide all the credentials needed for him or her to be an active and compliant participant able to create or invoke transactions. Finally, membership services also provide reputation. Reputation provides efficiently tracing the transactions of a particular individual under certain conditions for law enforcement and auditing. It also allows auditors to prove transaction member relationships. Now let's talk about the four key components in blockchain services: consensus manager, distributed ledger, P2P protocol, and ledger storage. First, let's talk about consensus manager. Consensus manager is an abstraction that defines the interface between the consensus algorithm and other Hyperledger components. Consensus manager receives transactions and, depending on the algorithm, decides how to organize and when to execute the transactions. Successful execution of transactions results in the changes to the ledger. Now going to the second one, which is distributed ledger. Blockchain services manage the distributed ledger through a peer-to-peer protocol, which is built on HTTP2 standards. Distributed ledger ensures the integrity and efficiency of blockchain by maintaining the state of the ledger. Now going to the third one, which is replication protocol. Replication protocol is a peer-to-peer protocol that is built on HTTP2 standards to keep the ledger in sync between the participants. It has many capabilities including bidirectional streaming, flow control, and multiplexing requests over a single connection. Most importantly, it works with the existing internet infrastructure, including firewalls, proxies, and security. This component defines messages used by peer node from point to multicast. And finally, the ledger storage. Large files are stored in off-chain storage and not the ledger. Their hashes can be stored on-chain as part of the transactions, which is required to maintain the integrity of the files. Ledger storage keeps the large files securely linked to blockchain. All the components in these categories emits events on the blockchain network that may listen for and to take action. Event Hub manages events across the distributed network. Talk about one of the key components of blockchain, chain code. What is chain code? Chain code is an application level code, also known as smart contract, deployed as a transaction to be distributed to the network and managed by validating peer as an isolated sandbox. All of the chain code transactions can only be executed within the transaction time window. Chain code services provide a highly secured and lightweight way to sandbox the chain code execution on the validating nodes. Initial implementation allows for chain code in Golang, Java and JavaScript are planned. Now let's see how secure container or other virtual technologies can support chain code execution. Though any virtualization technology can support the sandbox, currently Docker container is utilized to run the chain code. This environment is locked down and secured in a container with a set of signed base images containing secure operating system, chain code language, runtime, and SDK layers for Go, Java, and Node.js. Now let's go to secure registry. All the chain code services offered by blockchain are through secure registry. Secure registry ensures appropriate participant access to chain code. Let's go to privacy. How does chain code services maintain privacy? Transaction confidentiality requires that under the request of a developer, the plain text of a chain code, that is the code description, is not accessible or inferable by any unauthorized entity. These entities can be user or peers who are not authorized by the developer. Chain code functions call each other, but privacy is maintained through transaction confidentiality. Implementation of the chain code. Chain code for Hyperledger Fabric will implement three functions specified in the chain code shim. In addition to these functions, the chain code may include additional code to implement the necessary functionality expressed in the smart contract. There are three important functions that are specified as follows. Init. Init is called when you first deploy your chain code. As the name implies, the function should be used to do any initialization of your chain code needs. Next, it is invoke. Invoke is called when you want to call chain code functions to do real work. Invoke transactions will be captured as blocks on the chain. The structure of invoke is simple. It receives a function argument and based on this argument calls Go functions in the chain code with the string array as input. Now to the final one, which is, as the name implies, query. Query is called when you query the chain code state. Queries do not result in blocks being added to the chain. Queries return information in the response. The lower half of the slide shows some example code in Go that is from the demo application. It shows how business rules for smart contract can be implemented through a series of conditional expressions. If all conditions are met, an assignment to change field of the asset, example ownership, can be made to complete the transfer. Let's talk about how to model or design applications for blockchain. Modeling of a blockchain application can follow industry standard MVC architecture that includes blockchain logic. So it is called MVCB architecture: model, view, control, and blockchain logic. In the MVCB architecture, let's talk about view logic. What does this view logic do? View logic gives mobile and web UI access to interact with control logic. Now let's see what control logic does. Control logic coordinates between UI, data model, and APIs to drive transactions and chain code. So now let's look at the next block, which is data model. Data model, which can also be called application data model, manages off-chain data, including documents and large files. Finally, what is blockchain logic? Blockchain logic are the extensions of controller logic and data model in the blockchain realm. Controller logic is enhanced by chain code, and the data model is enhanced with transactions on the blockchain. For example, a Bluemix Pass application using Node.js might have a web front-end user interface or a native mobile app with back-end model on cloud and data service. The control logic may interact with one or more chain codes to process transactions on the blockchain.